Hello, Neda. Let me reply to some of the things that you asked me in your latest email. I found that probably this is better because I've been trying to get a hold of you in the last couple of hours, but I didn't get any reply, and that's fine. We just probably relaxing. After all, you have written two email messages with lots of information. So let me just address the last issue in both of your most recent emails, and it is the OneDrive. Yes, I did it, finally. Thank you for your encouragement. I know that you may be a little bit frustrated because of the speed with which I am replying. Finally, I managed, and not because it's hard, it's just because I've been so busy, busier than when we used to go physically to uni. It's amazing. So OneDrive is already up and going. I invited you to come to it. What I did was I downloaded the whole Google Drive folders and I uploaded them back to OneDrive. Please check that everything is in place. As far as I'm concerned, everything is there. I put everything back, and it's now on Google Drive, on OneDrive. So, going on the issues on your latest email. Based on what we discussed, we can use the manufacturing line model for other contexts, such as call centers, hospitals, blah, blah, blah. Yes, that's the idea. The thing is that we need to find like a basic kind of backbone of the model that basically addresses the main issues of queuing and probably some loop back and one or two stations or something like that, servers. Um, the contexts are different, and this is the challenge because in week 5, and this is what we are talking about here, right? Is it week 5? Yeah, it's the week where I propose to have different industries being covered. If it's not week 5, I'm sorry, but I'm pretty sure it is. So yeah, we can have that, but at the moment, I'm not that concerned with random variables and exponential arrivals and that sort of thing. That is going to come. That is basically what we do. We use those uh, math constructs to basically populate the model. But I'm not concerned with that. I'm concerned with us identifying 3 or 4 industries, and I think they have been already mentioned in the proposed outline, the proposed schedule, and to find an example, to find the common things, the commonalities, so that we can have like a basic model that then you can modify a little bit and use it in the different industries. Now the model is not complicated. All we want to do is be able to tell the story that models of simulation, a discrete event simulation, essentially are not that different, or in other words, that this technique may cover a wide range of different models, different situations, different contexts. The thing is that um, we want to do it like that. I want to do it like that because there is going to be students from different backgrounds. Most likely, most of the students would be operation management students, and that's fine. But there are going to be students from other walks of life. So in that case, it would be a good moment to have a number of examples that would apply, but we cannot go into developing specific model for each because at this point that's not the objective. The objective is to show them how they are all relying on these basic ideas. Of course, the challenge is what story are we going to tell on each of the industries? And that's where the big questions come. For instance, if you have a hospital environment, what is it that people are more interested in? Probably reducing the some kind of waiting time somewhere. Okay, that should be explained when we explain what a hospital emergency room is or whatever you want to model. Then the call center. What is typical of a call center? Call center maybe is how many operators you should have for the load, for the expected load. Well, that's the answer. That's the question. The answer to that question would come through simulation. In a telecommunications network, what is the capacity of a certain link that is connecting two endpoints? At which sides, at which ends, we have users exchanging information, sending emails or downloading applications or whatever. So what is the capacity of that link? All these questions we should be able to address and answer through a simulation model. Now, yes, it's a challenge because we need to actually describe things in different contexts, 3 or 4 different industries, and then find the right questions. And that's what I mean by the challenge. Um, Based on 1 and 2, you said, I have a questions. I don't know the difference between what we aim to cover in the lecture and what we aim to include in the lab. Well, the lab is a mirror to the lecture. The lab is where students are going to be asked to either use a pre-designed model or to build a model and work on it. And work on it with guideline, and the things that they're supposed to be answering would correspond to the things that we've been teaching in the lecture. So there is a correspondence, and that has to happen. So exactly how it happens, well, you're building it, you're helping me to build that through the exercises that you've been working on. In the lecture, I plan to basically tell the story of why simulation, the different phases of simulation in terms of how it applies, how it could be applied. But most importantly, the math concepts and the underlying theory that is not necessary to cover in great depth, but at least once in your life in a simulation course you should be dealing with, either because the instructor is telling you about it or because after you are being told about it or taught about it, you are supposed to do a few exercises just to make sure you understand. So things like, yeah, waiting times and contention and throughputs and those things, which are the concepts that we're interested in calculating, the variables that I'm interested in calculating on one hand. On the other hand, the math models that are typically used. A point process, and when you talk about the point process, and you talk about the count process, and with those two, then you can fix your attention to inter-arrival times, and then you talk about waiting times, and then you talk about uncertainty about those things, and then you introduce probabilistic tools to deal with those, which means um, probability distributions. And that's how it goes. About week 4, do you agree I write about well-known PMFs? I don't think you need to actually spend time doing that. And that's because I'm planning that later, towards the end of the descriptive and simulation part, we are going to discuss other PMFs and or distributions in general, so that the probability functions in general, and be more technical about when you use one and when you use the other. There's a whole bunch and big range of different um, distributions, but we're not concerned with talking about all those in the first weeks of the semester. Once they learn to understand what uniform means, constant, uniform, and exponential, those are the main three. And then we talk about others. Week 3, I added the concept of a state variable at the end of the document, and I appreciate your feedback on it. I'm lagging behind. Yes, I haven't done that. I will do. I think we need to move assignment 1 from week 2 to 3. Is it because there's not enough time? Um, I'm not quite sure. You'll have to be more explicit, please. Well, that's the latest email, and the previous one you asked me to check on week 1, which I haven't done, certain issues. On week 2, you said you made some changes to week 2, only the figures. I'll take a look at it. Week 3, you uploaded the document for lab 3, not sure is the right week for this doc or not. However, I chose it based on what was mentioned in week 3 material. It's basically how students need to create a simulation model in Simio. I'm going to check those things. As I promised, I'll have to do it. So I think that covers all. But if there's anything I didn't answer, please tell me. If there's anything wasn't clear, please ask me. Other than that, I hope that you're doing fine. You stay healthy. You are eating well. You are having some fun with yourself. You're exercising and all those good things that happen to you. All right. Thank you. Bye.